Again, we have two equations in a stoichiometry problem. We're going to need to construct two mole-to-mole ratios. But first, we need to balance these equations. Be sure to review balancing chemical equations before the quiz. Next, we need to identify the chemical that's in common to both of the equations. Here, the chemical that's in common to both equations is P4O10. We go back to the problem, and the problem gives us an amount of phosphoric acid, H3PO4, and it wants to relate that to oxygen gas at STP. We start with the amount of phosphoric acid, and we know we need to convert that to moles so that we can compare it to another chemical. It's in kilograms, so we first do the conversion from kilograms to grams, and then we can go from grams to moles using the formula weight. So these calculations taken together are going to give us the moles of phosphoric acid, H3PO4. We want to relate phosphoric acid to our common chemical, P4O10. That's done using this second chemical equation, so we want to make sure we use the chemical with the appropriate coefficient. We set up our conversion factor using our balanced chemical equation. It tells us 4 moles of phosphoric acid are produced from every mole of P4O10. When we check out the cancellation, we see moles of phosphoric acid cancel out, and we have moles of P4O10. The next step is to relate P4O10 to the chemical of interest, namely O2. So here we have two mole-to-mole conversion factors. The first is going to relate the amount of the chemical that we're given to our common chemical. The second mole-to-mole conversion factor is going to relate our common chemical to the chemical of interest. We know this is set up correctly because we've used the appropriate coefficient values, and moles of our common chemical cancel out. We end up with moles of our chemical of interest, oxygen gas. The last step is to convert moles of oxygen to volume of oxygen at STP. We remind ourselves that a mole of O2, or any gas at STP, is equivalent to 22.414 liters. We've set this up correctly, so the moles of O2 cancel out. The only unit that survives is liters, which is exactly the unit we want. We do our math, we get our numerical answer. Now we need to go back and check sig figs. 2, this is exact. This has 4 sig figs, exact, exact. Remember, exact conversion factors do not impact sig figs. This is 5 sig figs. Looks like we're going to be limited to 2 sig figs. We have to write our number in scientific notation as 4.3 times 10 to the third liters.